The point of this video is I want to talk about the Truth Engine. What the hell is a Truth Engine? Before I get into that, I want to do a little recap on blockchain in general. So a blockchain is pretty much a spreadsheet that is stored amongst a bunch of computers all over the world versus a spreadsheet like one your bank has that's stored in a centralized server. It's done this way for several reasons. One of them is for censorship resistance. It's easier to pinpoint a centralized server and go shut it down if someone ever felt the need to, versus if a network is decentralized and there's a bunch of computers all over the world. These computers are known as nodes or miners. A miner is just an entity, a person, or a group of people or a company that owns mining equipment that is used to support the network. They just run like some complex math problem or like a puzzle to show that they actually put in the resources to validate a block of transactions. If there wasn't no cost involved with claiming that you found the proper sequence of transactions in a certain period of time. So every block is 10 minutes, and a block is a batch of transactions. So all the transactions that happen all over the world within the network, and every 10 minutes is included in the block. But these miners need to make sure that there's no fraudulent transactions in these blocks. So they make it very expensive to try to claim that you found the right block, so there's no malicious actors. Okay, so anyway, a blockchain. It's a decentralized ledger that holds all the transactions separated into batches. And each batch or each block, the reason it's called a blockchain is because each block includes in it a code of its parent block. What the hell does that mean? Okay, so imagine you can get a batch of transactions, and then you took this data and you collapsed it down into this one string of characters known as a hash. And then that hash is included into the next block that includes all the transactions plus the previous block's hash, and so on and so forth. And so that's what chains these blocks together, is the hash from the previous block, from the parent block. So in order for someone to change any one block, you would have to change the entire history. All the history of the entire blockchain is included in every block. It just makes it really hard to convince everyone to achieve consensus to change any one block, because they would have to change, or they would have to roll back the chain up to a certain point, whatever block height or whatever block number that discrepancy is, or anyway, whatever. I'm not going to get into all this shit because I'm not super technical, but I just wanted to sort of talk about like a basic blockchain. I don't want to call Bitcoin basic, but it's very simple. It's just a bunch of accounts that have balances in them, and the only people who can control the accounts are the people who have the keys, the private keys to that account. The governance mechanism, the miners, they ensure that no one can ever send more Bitcoin than was ever received into that account. And that's where the whole governance mechanism comes from. That would be called, I guess, double spending. If you try to spend more than what you received, like if you have a Bitcoin and you try to buy two things at the same time, you only ever receive the one Bitcoin, so you can't spend two. I guess what made Bitcoin so revolutionary is because they solved what's referred to as the Byzantine General's problem, and the way that they achieved the consensus mechanism. And the Byzantine General's problem, it's like this old problem, this old puzzle where they had to figure out how these four armies that were all trying to attack this one empire in the middle. This empire in the middle was too powerful for any one army to beat on their own, or like 2 armies to be on their own. Even 3 would be too risky. So all 4 armies had to attack this central empire, this common enemy that they all shared. They all had to attack together at the same time. Because if one reached the castle first, they'd be put down, and then the next one would be put down. If they attack one at a time, they wouldn't be able to defeat it. It would have to be simultaneously, so that way the common enemy's resources would be spread thin. And obviously all these armies were kind of far apart, so they weren't able to communicate without sending like some messenger. But they all had a problem. They didn't fully trust each other because they weren't really like friends, but they did share an enemy. So each army was equally suspicious of every other army. The idea is they all had to synchronize their attack. They had to coordinate. So they had to send messengers in order to ensure that one of the messengers wasn't intercepted or apprehended, and then the message was intercepted and like changed, because any 1 or 2 of the armies could sort of turn against one of the armies or 2 of the armies and tell them to attack at a certain time, and then actually they would stand down, and then these 2 armies would just go meet their demise. So that was the whole problem. Nobody trusted each other, but they all had to work together to achieve this common goal of destroying this empire, which was their enemy. And I guess Satoshi Nakamoto solved this through its consensus mechanism. When a miner claims to have found the proper sequence of transactions, all the other miners need to check and verify. And also the algorithm is very resource intensive to make sure that it would be too costly to try to change a block and profit from that. So changing a block or coming up with a fraudulent block would be too costly. I don't know. I don't really know the nitty gritty of the whole consensus mechanism. But the point is that the miners work together to reach agreement to verify and validate every block. It's basically a spreadsheet with a bunch of accounts that hold balances, and the miners make sure that no one can ever send more than they've received into their account. And that's it. Ethereum came about 5 years after Bitcoin, like in 2014. They probably started developing it. It launched, I think, 2015. And what they changed, or what they added to Bitcoin, so Ethereum is basically that. It's a distributed ledger with a bunch of balances that is secured by miners who have to perform this really hard puzzle that uses up electricity to prove that they're honest. But what Vitalik Buterin did is he added a different type of account to this new blockchain. He had the ability to have code be in control of a certain account. So you have personal accounts and you have contract accounts, smart contracts. So he added the ability to support code on a blockchain. Bitcoin was just code that secured the balances on these accounts. Ethereum is that. It's code that secures balances on accounts. And, they make sure that no one could ever send out from an account more than they ever received. But they also made a different type of account where you could run code. So a smart contract is pretty much just a little snippet of code that lives at an address or at an account. And in order to run that code, you need to send a transaction, which is pretty much a fee that you're paying to the miners to run the code. And this fee is referred to as gas. So Ethereum is pretty much just like Bitcoin with another level of utility, which is it supports smart contracts. And so this other level of utility is referred to as the Ethereum Virtual Machine. It's all the accounts and balances, all the balances in the accounts at this current state. And that includes the smart contracts. So the smart contracts also have balances in them. Let me just share my screen and read along this ethereum.org website. This is a smart contracts section. So a smart contract is simply a program that runs on the Ethereum blockchain. And that's why I just wanted to cover what a blockchain is. It's just a decentralized spreadsheet with a bunch of accounts on the spreadsheet, and each account has a balance. And the governance mechanism just makes sure that no account could ever spend more than it ever received. And then Ethereum added a second type of account, which is what I was referring to with its smart contracts. It's a collection of code and its functions and data, its state, that resides at a specific address on the blockchain. Smart contracts are a type of Ethereum account. This means they have a balance and can be the target of transactions. However, they're not controlled by a user. Instead, they are deployed to the network and runs as programmed. So anyone that's a coder could develop a piece of code like an app, and then you pay a transaction fee to embed this code in the blockchain, and then it just lives there forever. And in order for it to function, someone needs to interact with it by paying another transaction fee, and it's public, so anyone could just go and use this public virtual machine. And that's why they call it the Ethereum Virtual Machine. Anyway, so user accounts can then interact with a smart contract by submitting transactions that execute a function defined on the smart contract. Smart contracts can define rules like a regular contract and automatically enforce them via the code. Smart contracts cannot be deleted by default, and interactions with them are irreversible. That's really cool. So the cool thing about a smart contract is that, like it said, it defines the rules like a regular contract, and it also enforces them, unlike a regular contract. And this is exactly the part that allows the Truth Engine to exist. The Truth Engine is basically a smart contract. And moving back to HEX, so this back here is my drawing of a blockchain. So these are the blocks, of course. Okay, each block is a batch of transactions. For Bitcoin, it's 10 minutes. I forget what it is for Ethereum. It's like 12 seconds or something like that. Every 10 or 12 seconds, or I don't know. All the transactions in the network are batched together into, well, a batch. And they do this puzzle, this algorithm. They run it and they validate that all the transactions in that batch are correct. And then this block includes the hash from the parent block. Let's say this is moving forward in time in this direction. So this is the future over here. And this is the current state, the current system state. We're at this block height. So this block will include the hash. Let's pretend this is the hash, which is just a collapsed version or a compressed version of the previous block, which includes the hash of the previous block, which includes the hash of the previous block, and so on and so forth. And then the future block will include the hash of the present block, and so on and so forth. And so if anyone ever tries to tamper with like a let's say we're here now and we try to claim that we have 2 Ethereum instead of 1, then all the other computers would have to verify the previous block to see if that account received 2 Ethereum. And they can't lie because all the data is recorded, and the data from the previous block is recorded, and the previous block is embedded in those in those hashes. So the entire history of the blockchain is in every block, essentially. So it's really hard to lie because they could just decode it and see that someone's lying. And that's the whole idea of the security model. But there's another layer beyond just the spreadsheet that verifies spending or the balances of the accounts. It would be the Ethereum Virtual Machine, which is like, I guess they call it like a decentralized supercomputer. So all the computers that are, or the nodes that are spread out all over the world, together they create one big monster known as, or one big supercomputer known as the Ethereum Virtual Machine, which is pretty much like the current state of the system at any given time. And the state of the system, again, it includes the balances of all the accounts, personal accounts, and also smart contract accounts. Back to smart contracts and back to the Truth Engine. So the whole idea of a smart contract is that it has rules, and smart contract has rules, and they execute or enforce. So the code or the contract doesn't care about anyone's feelings. So it just does what it's programmed to do. So the rules are: you walk up to the virtual machine, think of it like a vending machine. You insert your coins that you bought at a different smart contract, which is known as a DEX, like Uniswap or 1inch or Matcha or whatever smart contract. So you acquire these coins, the HEX tokens or coins. You insert them into this virtual vending machine, and then you enter a duration. When you're entering a duration, you're essentially making a promise to yourself, or you're entering into an agreement. You're entering into a contract, and you're saying, I'm going to lock up this amount of coins for this amount of time, and then you start your stake. It burns those coins. That's why I have this fire. So you throw those coins in the fire, but then it prints out like this little slip. It doesn't really, but I mean, it's digital, so it kind of does. And it's like a receipt, and it gives you your T-shares, like I explained in the previous video. Now, if you come back sooner than you promised, the contract has no feelings. It's just going to say, okay, this is what you promised, and you said you would come back in 90 days, and it's only 45 days, and you're trying to cancel or end your stake. So according to our agreement, you're going to get penalized. This is when we get to penalties. Never break your contract obligations. The general rule is good for any contract you have ever signed in your life, but it's particularly true for smart contracts because these are self-enforcing. The penalty for doing an emergency end stake can be up to 100% of the stake, depending on how far the stake is from maturity and how much interest is accrued in relation to the principal. So let me just come back here. So like I was saying, this whole video was supposed to be about the Truth Engine, which we're finally getting to now, but I just kind of wanted to do a little recap on what blockchain is, and then what a smart contract is, the fact that it's pretty much just code with rules coded into this program or into this self-executing contract. And so the rules in HEX are that that there's penalties to enforce the promise that you make to yourself. Essentially, when you walk up to this HEX virtual vending machine, you're kind of making a promise, I guess, to the code, but the code doesn't really care. It's not alive. So you're really just making a promise to yourself, and the code just holds you up to that promise. And it holds you up to that promise based on the rules of the game that you're agreeing to by making the promise in the first place. So these are the rules of the game. The contract has a feature whereby a user can terminate their stake before the committed time. So if you want to go ahead and end your stake early, before you said you would, you're free to do whatever the hell you want. The contract doesn't care, but it will hold you up to it. The user pays a penalty for this, and that's what you agree to when you make the contract. The contract calculates the payout for half of the days committed. So, for example, if you commit for 52 weeks, half of that period would be 182 days. So if you end early, your penalty would be what you earned for those first 182 days. And it subtracts that from the funds returned to the user. It always applies at least a 90-day penalty, so that's like the minimum penalty. For example, I stake for 52 weeks, about a year, and I end the stake after 266 days. So I commit 52 weeks and I only serve out 38 weeks, right? So the contract calculates the payouts for the first 38 weeks, which is 182 days. And that'll be the penalty. It flags that as a penalty. The funds returned to me are then my principal plus days 183 to 266. So it's the days after this. So that's my penalty, days, the first 182 days. And then I only get the days 183 through 66 plus my principal. So the first 182 days, the first 50% of the committed days is the penalty. If the user ends the stake before half their days are served, or if the stake is less than 179, because remember over here, the minimum penalty is 90 days, the penalty can cut into the principal. The contract just calculates half the days or 90, whichever is greater, estimating for future days unserved, and subtracts that from the funds earned. So let me just draw that out to make it easier to see. I'm going to erase my beautiful drawing of the HEX virtual vending machine. Okay, so this is a timeline. We're going to use 1,000 days. So you decided to stake for 1,000 days, right? So the 50% point would be day 500. The maturation date would be day 1,000, and obviously day 1 is when you started the stake. So this would be 250. So the minimum penalty is right here. This is 90 days. And so basically with this part of the, let me close this. What this part of the paragraph was saying that anything less than 179 days, the minimum penalty is 90. So let me just draw another one. So because the minimum penalty is 90 days, if you stake anything 175 days or less, then that's going to be your penalty. Always. Because if you double that, it would be 180. That's what I was trying to say. So this will be the penalty. Always. If you end early. If you honor your commitment and you end once the stake matures, there's no penalty. Unless you wait past the grace period, which is 14 days. And then it starts to bleed out at 1% per week. And then it goes to 0 in 2 years, I believe. So you have a 14-day grace period after your stake matures. Before it matures, the minimum penalty will always be 90 days worth of your yield. Or half, whichever is greater. This is just a lot of words to describe this simple little formula. Principal plus payout minus penalty. So let's just fill in these numbers. We need the payout. So let's come up with like a simple payout. So let's say it's a stake of 1,000 days. And we're going to try to come up with a T-share. It's going to be like somewhere around here. Let's see. No, that's half of a T-share. Okay, so we need more than that. Just do 500 more. That works. Okay, so we're gonna do 15,500 hex was the principal. The duration is 1,000 days. You get 1 T-share. And well, the principal is 15,500. The payout would be 6520. 15.5K. And the yield 6.52K. Okay, so that's if you've this is the situation if you let the stake mature. You commit 1,000 days and you serve 1,000 days, right? But right now we're trying to come up with a penalty, which means that you didn't serve your 1,000 days that you promised yourself. You only served, let's solve for 1,000 days. Remember, the formula is principal plus payout minus penalty. The penalty equals principal plus payout minus penalty. So something happens in day 600, you decide to end it. So it would be 15,500 plus, again, you ended on day 600, ended stake. We need to solve for the payout. Excuse me. The reason I wanted to do 1 T-share is because you're earning 6 hex per day because you're holding 1 T-share. So 6 times 600 equals 36. 3,600. This would be the payout, and then minus the penalty. And that's what we're trying to solve for. The penalty would be half of your committed days, which is 500, right? Half of 1,000 is 500. Committed days is 1,000 divided by 2 equals 500. And then you're getting 6 hex per day because you have 1 T-share times 6 equals 3 Gs. So you have 3,000 equals, and that's super easy to solve for because you just do 15,500 plus the difference of this is 600, so it'd be like 16,100. That would be your payout when you ended at day 600. So now let's say you ended at day 500 or 400. Let's do it over here or underneath. So you ended early end stake at day 400. So the principle's still the same, 5,500 plus, and then so now you have 400 times 6 hex per day. What is that? 4 times 6 is 2,400 minus half the days committed is still 1,000, so it's still 3,000 because everything else is still the same. So half of 1,000 is 500 times 6 is 3,000. So now you're going to have something negative here. You're going to have a penalty that is 600 hex more than what you earned. So that 600 hex is going to bite into your principal, which will equal 14,900. And it's that simple. That's how you calculate your penalty. Principal plus your payout minus the penalty. So the payout would be the days that that you served, days served times payout, which is, it depends on how many T-shares you have, right? So if it's one T-share, it's, the payout per T-share per day times the days you've served, right? So that's why I wanted to do one T-share, so it's just easy. It's 6. So it'd be days served times 6. The penalty is half days committed. So it's days committed divided by 2 times payout. Whoops. And then you subtract these two. And then you add that to the principal. So this is if the penalty is bigger than the days committed, which is usually if you serve less than half, then it's going to eat into your principal. In some cases, it could eat all of your principal. So anyway, that's it. That's this is what the contract does, or these are the rules of the game that the contract follows. The contract, which again is referred to as the Truth Engine, because all it does is it enforces the rules of the game. It does not lie. It does not favor anyone. It will not stop until you are honest. That's a paraphrase from the Terminator. So that's pretty much the way the Truth Engine works. It enforces the rules of the game by just executing the code. It makes you keep your promises. So thanks for watching. Sorry I rambled. If I did, if you learned something, well, I'm happy that I was able to make a useful video to you. Just please hit the like, share it with anyone you think might benefit from watching it. And yeah, my next video, I don't know. I'm going to try to do at least one video a week. So I'm not sure what it'll be on. All right. Thanks again.